Sharing prescription drugs with others can be dangerous. Is this a common occurrence among teens? Or the National Association of Colleges and Employers stated that the average starting salary for students graduating with a bachelor's degree in 2010 is $48,351. Is this true for your college? In the last unit, we used sample data to estimate the value of an unknown population characteristic. In this unit, we will not be estimating. We will use sample data to test some claim or hypothesis about the population to see if it is plausible. So what is a test of hypotheses? A test of hypotheses is a method that uses sample data to decide between two competing claims, hypotheses, about the population characteristic. In other words, is the value of our sample statistic an occurrence due to random chance, or did something very unusual occur? For example, the average Okia bed holds 420 pounds without breaking. Mr. Fateh weighs 400 pounds and the bed breaks. Does he have evidence that Okia made a faulty bed? We're not estimating the amount the bed can hold, we are testing the claim whether it actually holds an average of 420 pounds. A bed breaking at 400 pounds means that either something really unusual occurred, or Okia beds don't really hold an average of 420 pounds. The original claim is that the bed holds an average of 420 pounds. This is believed to be true of all the Okia beds. So our original claim mathematically looks like this. The symbol H0 represents H0. This is called the null hypothesis. This characteristic is assumed to be true. We are assuming that the mean weight that it holds is 420 pounds. The alternative claim is that the bed doesn't hold 420 pounds, but in fact it holds less than that. So our alternative hypothesis is that the mean weight of the bed holds less than 420 pounds. HA is called the alternative hypothesis. This is our opposing claim. When writing hypothesis testing statements, you're usually trying to determine if the original claim, the null hypothesis, is believable. The hypothesis statements are always about the population, never about the sample. Notice we use population notation to show the null and the alternative hypothesis in the last example. The form of hypotheses looks like this. Our null hypothesis, H0, is always the population characteristic, so some symbol about the population, equal to the hypothesized value. The null hypothesis always includes equal. It will be no other symbol except for equal in your null hypothesis. The hypothesized value is a specific number determined by the context of the problem. Our alternative hypothesis looks like this. We have population characteristic, the same exact symbol we used in our null hypothesis, but it could be greater than the hypothesized value. So notice these two symbols are the same, and the hypothesized value is also going to be the same. Whether it's going to be greater than or less than is determined by the context of the problem. Our alternative is that our population characteristic is less than the hypothesized value. Or lastly, we may not know which direction, and so we just say not equal to. Less than and greater than are considered to be one-tailed tests because you are only interested in one direction. Not equal to is called a two-tailed test because we're both interested in both directions, above and below the hypothesized value. We're going to practice writing some hypothesis statements. So sharing prescription drugs with others can be dangerous. A survey of a representative sample of 592 U.S. teens aged 12 to 17 reported that 118 of those surveyed admitted to having shared a prescription drug with a friend. Is this sufficient evidence that more than 10% of teens have shared prescription medication with friends? We're going to state our hypotheses. Our null hypothesis, or H0, is always equal to. We need to figure out which symbol we're using. So what is the population characteristic of interest? We're interested in the true proportion of teens who shared prescription medication with friends, so that would be P. What is our hypothesized value? We believe that it's going to be 10%. And what words indicate the direction of the alternative? we're looking to see if more than 10% of teens have shared prescription medication. So our H naught is always equal to, so we believe the proportion is going to be equal to 10%. Our alternative is that the proportion is going to be more than 10%. Compact fluorescent light bulbs are much more energy efficient than regular incandescent light bulbs. EcoBulb brand 60-watt light bulb states on the package the average life 8,000 hours. People who purchase this brand would be unhappy if the bulbs lasted less than 8,000 hours. A sample of these bulbs will be selected and tested. What is the population characteristic of interest? We are looking at the true mean life of the light bulbs. The hypothesized value is 8,000 hours. And what words indicate the direction of our alternative? Less than. Our null hypothesis is always equal to, so we believe the average is equal to 8,000. Our alternative is that we believe it's less than 8,000. Because of variation of the manufacturing process, tennis balls produced by a particular machine do not have the same diameters. Suppose the machine was initially calibrated to achieve the specification of mu equals 3 inches. However, the manager is now concerned that the diameters no longer conform to this specification. If the mean diameter is not 3 inches, production will have to be halted. What is the population characteristic of interest? We are looking for the true mean of the diameter of the tennis balls. What words indicate the direction of our alternative hypothesis? Is not. So we don't know if we're talking about over or under 3 inches, we just know it's not going to be 3 inches. So our null hypothesis is always equal to, so mu is equal to 3. That's what we believe to be true to start with. Our alternative is that it's not going to be 3, not equal to. For each pair of hypotheses, indicate which are not legitimate and explain why. So stop the video here and take a moment, go through the next few examples and determine whether or not they are legitimate statements or not legitimate statements. This is not good. We only use greater than, less than, or not equal to for our alternative hypothesis. This one's bad too. We always use population notation, not sample notation when we write our hypotheses. This one is good. We have our population parameter, which is p, and we have equal to for our null hypothesis and not equal to for our alternative. This one's not good. Both values have to be the same in the null and the alternative hypothesis. And lastly, this one's not good either because our original hypothesis, H naught, has to be equal to no matter what. The null hypothesis states that the claim we are seeking evidence against, the probability that measures the strength of the evidence against a null hypothesis, is called a p-value. Small p-values are evidence against H naught because they say that the observed result is unlikely to occur when H naught is true. So we assume that H naught is true, but if the statistic we get is so unlikely, there might be enough evidence to say that it's not really true. Large p-values fail to give convincing evidence against the null hypothesis because they say that the observed result is likely to occur by chance. The final step in performing a significance test is to draw a conclusion about the competing claims you are testing. We will make one of two decisions based on the strength of our evidence against the null hypothesis. Either we're going to reject H naught, or we fail to reject H naught. If our sample result is too unlikely to have happened by chance, assuming that H naught is true, then we're going to reject H naught. Otherwise, if we don't have enough evidence, we'll have to fail to reject H naught. So in other words, consider a murder trial. Our null hypothesis before we even begin the trial is that we assume the defendant is innocent. That is our null hypothesis. The alternative hypothesis is that they are guilty. To determine which hypothesis is correct, the jury will listen to the evidence. Only if there is evidence beyond a reasonable doubt would the null hypothesis be rejected in favor of an alternative hypothesis. So there has to be enough evidence. If there's not convincing evidence, then we would fail to reject the null hypothesis. Remember that the actual verdict that is returned is guilty or not guilty. We never end up determining the null hypothesis is true. So we never determine that someone is innocent. We determine whether they are guilty or not guilty. And this only happens if there's not enough evidence to say it's not true. So we will make one of two decisions. We will reject the null hypothesis, which means that the defendant is guilty, or we're going to fail to reject the null hypothesis, which means that the defendant is found not guilty. So a fail to reject the null hypothesis decision in a significance test doesn't mean that H0 is true. For that reason, you should never accept H0 or use language implying that you believe H0 is true. Lastly, in a nutshell, our conclusion in a significance test comes down to the following. If your p-value is low, we reject H0, and we conclude that HA, our alternative hypothesis, in context. If our p-value is large, we fail to reject H0, and we cannot conclude the alternative hypothesis. In class, we'll be discussing more about what this p-value is and how we find it.